So before we set up our Lambda to subscribe to an SNS in this video, I wanted to talk about some of the differences and even how you can use these two together, SQS and SNS. If you haven't seen my previous video on SQS, go back and check that out. I'll link it in the description. So there's a lot of similarities between these two services, but they're used in conjunction or slightly differently. They both kind of use this same producer consumer terminology. With SNS, it's a pub sub terminology, so there's publishers, topics, and then subscribers. So subscribers subscribe to topics, and publishers publish messages or events onto those topics. Once an event is on the topic, it gets reproduced and sent out, emitted to all of the subscribers, right? So one event will get published into our topic here, and then all of these subscribers that subscribe to that topic receive that event. So there could be one event gets fanned out and turned into many events. So that's kind of the general idea of an SNS. With SQS, we still have this producer consumer terminology. You have a producer, it's going to produce an event onto your queue. But the difference here is that event gets made available on the queue, and then whatever consumer, there could be many consumers, just like we have many subscribers here, whatever consumer picks that event off the queue, that event is gone, it's done, and none of the other consumers will get it. So you could have one event, and it's only ever going to get processed by one consumer. So if you have like 5 different services listening to a queue, there's no way that they would all 5 get that event. So that is kind of the situation here. If you have an event that you want, or a message that you want to be consumed by many subscribers, many different services will pull it off and use it. That is kind of the magic of SNS here. If you don't want many subscribers, or if you just have a single consumer that needs to process these events, that's what SQS is used for. So what is a way we can use both of them together? As a combined example, and really for really robust systems here, we can combine the two, and we can alleviate certain concerns that you might have with a distributed system. So for example, let's say we have tons of producers, we're getting tons of events coming out into our SNS. All of these events are eventually going to end up bombarding your service over here. So hypothetically, if we didn't have this SQS and it was just a direct notification to your service, you could get overwhelmed pretty quickly and you could fail to process these events. There wouldn't be great retriability or replayability from SNS. So that is where we can kind of add this little decoupling layer in between. And now what happens is SNS can produce as many events as it wants, and these events will all come to our queue that sits in front. And this queue kind of acts as the guardrails or the guardian of your service almost. So even if there's thousands and thousands and thousands of events coming in, your service will pick them off and process them at a rate that it can handle and that it can scale to. If you're using Lambda, like we did in our previous video with SQS, your Lambda would scale up and kind of replicate itself to handle that increased load. So there's sort of a real world example here. You'd use an SNS when you're producing messages or events that you want many services or many consumers to receive and process, do slightly different things with, and then you would use SQS as kind of like a decoupling agent. So anytime one system wants to call another system, you'll very frequently see an SQS in between. This is for reliability, just in case your service is down, maybe the network is down and this request failed initially, maybe it times out, there could be many reasons, but that's where SQS comes into play. Yeah, so hopefully this kind of outlined some of the differences between SNS and SQS, and also outlined how they can be used in combination together as well. Okay, so let's hop into the AWS dashboard now, and we'll set up SNS here. All right, so I'm on the console home. If your console looks a little bit different than this, it's probably because you have the old console view. I've opted in to try out the new AWS console view. I think this is coming for this will kind of be the main one, the new one coming June 22nd. So you might be already seeing this and you might have the old version, but regardless. So I'm signed in. I'm going to go to simple notification service. You can search up here too, SNS. And we're going to create our topic. So we're going to call this orders topic. So we're imagining that we're, next step. Let's imagine we're creating some service, like some order fulfillment service. So users will on the front end click a buy now button or one-click buy, similar to what you can do with Amazon.com. But you can hit that one-click buy, and then we're imagining that we want that event to kind of asynchronously trigger that order flow so that the user isn't held up waiting, maybe 10 seconds, 5 seconds for a bunch of different services to be called, and a bunch of different APIs to get back to it. So with this, they just emit a single event, basically just publish a message with SNS here, and that will kind of, this handles all of that. It'll asynchronously publish out to all of our different consumers, and like our delivery fulfillment consumer, for example, can pick up a message right off of here. It'll consume a message. Our products inventory service could also consume a message from here too. So that's the idea here, just orders topic. So consumers will subscribe to this orders topic, and then some service, like probably our orders service, would publish to this topic. So when the order service gets an order, it'll publish a message to orders topic, and then whatever consumers we want will consume the messages off that topic. Just like SQS, you can do FIFO, first in, first out. That preserves ordering of messages, but keep in mind when you do that, the subscription protocols are limited just to SQS. So only SQSs could subscribe to consume messages, could subscribe to this topic, basically. So if you do standard, you get the full range. So you could have a Lambda subscribe, you could call a third-party HTTP endpoint, you could send text messages. You kind of have the full range of options, but you don't get ordering preserved. So events 1, 2, 3 might not come in that order. They could come 2, 3, 1, etc. You're not promised that. So if you really need FIFO, go ahead and do it, but it'll take a little bit more work to couple everything with SQS. For us, just for simplicity, we'll use standard, and we'll kind of accept these risks that come with it too. All right, orders topic. Don't care about display name. This is all fine here. We could just leave everything default. We'll change these as needed. So we'll create our topic. All right, so just like that, we have our topic set up. You can see all the subscriptions. So this would be all of our Lambdas, or I don't know, HTTPS subscriptions, or anything else, right? Anything that subscribes to consume messages that are published to this topic would show up right here. We can create a subscription here, so we could add a new one directly from this page. Another thing we can do, similarly to what you can do with SQS on the dashboard, is publish a message. So this would be nice for testing, testing out your topics or your consumers, etc. So you can publish whatever message you want. So I don't want to send one yet, so let it cancel here. So next step, let's create 2 Lambdas. So these 2 Lambdas will be our kind of pretend or mock consumers that will subscribe to this topic. So let's go over to Lambda, and I'm going to create 2 functions. Author from scratch. I'm going to do delivery Lambda. So this hypothetical Lambda would handle deliveries. So it would consume whenever users order, it would consume the message, and it would start the delivery process. So it would start shipping, maybe print a shipping label, etc. Okay, so we'll create the function. All right, so the function's been created, and we can add a trigger just right here. So if we click add trigger, select trigger, we'll do SNS, and here's our orders topic. So we are now subscribing this Lambda to consume messages from orders topic. So we'll hit add, and this handles automatically setting up permissioning. If you have a more complex use case with your SNS, you might have a custom access policy permissions with your SQS. So your Lambda might need to have different roles attached to it to be able to access your SNS. But I'm assuming if you know how to set those policies up, you also will know more in depth how to set your Lambda up with its permissions, with its roles. Okay, so it's subscribed. So this Lambda will get events. It'll consume events from orders topic. One thing I want to do as well here, just put it in an environment variable. I'm going to call this Lambda name, and we'll say delivery Lambda. and we'll use this later in code. We'll be logging out so we can see the different lambdas that we're running here. So we'll say save. We'll log out that value later. Okay, so that's good for now. We don't have any code uploaded, so it's not gonna actually log anything or do anything. It's just an empty lambda. But let's go back and let's create one more lambda. So I'm gonna call this product inventory lambda. And when users place orders, this lambda kind of acts as our warehouse. So this would kind of store, this would interface with the database that stores all of our products, right? So our product count, when a user orders something, we need to decrement the count that we have remaining, so other orders can't come in and users can't order products that don't exist anymore. So runtime go 1.x, architecture is 86, that's fine. And we'll create this one. And just as before, we'll add a trigger, SNS, and we'll choose our topic. Click add. And just like before too, let's add an environment variable. And this is product inventory lambda. Save. Okay, so we have these two empty lambdas set up. They do absolutely nothing. But what we can do is check their CloudWatch logs after we publish an event. So let's quickly do that. We'll go to SNS. We'll choose our topic, orders topic, and now we can see the two subscriptions. We have product inventory and delivery lambda. So these are two subscribers that consume messages that get published to this topic. So let's test that. Let's publish a message. I'm gonna leave these blank. I'm gonna put in order ID, and we'll say 123, and then we'll just give this a timestamp. And I'm going to get the current epoch here, and just put that in for the timestamp. And that's an int. Okay, so the idea would be the consumers just pretty much need the order ID. With the order ID, they can go look up the order details from the order service. So they can, this is really the only information they need. This timestamp, possibly we could use it to determine if we're already processing an order, ordering the same product, right? So maybe that would help with some cases where two users ordered the same product and we need to figure out which one gets it, which one we need to say, hey, that product is no longer available to. But yeah, they'll look up the rest of the information from our order service with this ID. Okay, that's it. Don't need message attributes here, and we'll hit publish. Okay, so that was published. Now we should be able to check out these subscriptions and view their logs. So I'll go back to Lambda. I'm going to open up both of these different tabs. And we can go to monitor, view logs in CloudWatch. And similarly, while that loads, let's do the same for product inventory. View logs in CloudWatch. And we'll wait for it to load. Okay, so we see here's our first log stream. And it's just an event, basically. So we received a request and the Lambda tried to process it, but we have no code to run, so it just ran through and closed. Same thing for product, inventory, same exact thing. No code, no logs, we just received the event, so we booted up the Lambda and then it closed because there's nothing to run, nothing to do. Okay, so that is how we set up, just very briefly, very quickly, how you set up SNS and also subscribe consumers to it. So you could do this with any other service you'd like. One other piece I'd like to cover really quickly. So say you don't use Lambda, say you have like an external third-party microservice or API that also you want to have consume these events. We can create subscriptions similarly. And right here you see the delivery retry policy for HTTP/S. So this is like the retry policy. When it tries to publish these messages to consumers, you set up, you can specify how many times you want to retry, delay between when we receive the message and when we publish it, all of that, back off functions, so you don't spam your third-party service. So it'll retry, it'll back off, it'll retry, and then back off again. And to do that, you can create a subscription. And under protocol, this is all the subscriptions you have available to you. So if this was a FIFO, if this was a FIFO topic, the only one you would have is SQS. But because we're just a standard SNS topic, we have a wide variety of things we can choose from. For this, you can do HTTPS, and you would put in your endpoint here. Same thing for HTTP. You put in your API endpoint. All right, so maybe you have some API that looks like that. You have an endpoint set up that just handles consuming these messages. So SNS is smart enough to publish messages to there. And here you can also specify individual retry policies for this subscription too. So the one we saw before was kind of the generic retry policy, but this is an optional step, and you could specify detailed retry policies for each subscription. Yeah, so there's another option you could do. We won't do that today. All right, so anyways, we have these two subscriptions. We got 2 lambdas and 1 topic. So let's write the code now for these lambdas, and let's push that up. So to do that, we can look at some sample function code given here under SNS. On AWS, I'll put these docs in the description, but this is the Lambda developer guide, and I'm looking at SNS sample code. So you see here, events.records 0. So records is it's an array, right? It's a list of records, but they are hard coding and 0. So why the Go example does use a for loop, so it's a little bit safer. But Python, for example, also hard codes in the 0. So why are we doing that? If you actually look in the SNS documentation under reliability, there's a guarantee that all notification messages will receive a single published message. So that is why this documentation, it appears to be pretty sloppy, but that's why they're actually hard coding in 0, and they're not checking to see, are there 20 messages in here? Part of the contract or the policy or the guarantee of SNS, like when you're using Lambda with it or any other consumer with it, there's 1 message at a time. They do this event.records with an array because other event producers will sometimes produce events with multiple records in them. So that's why they do it. It's to have a uniform payload, a uniform body. So that's why records is an array here. But with SNS, it is guaranteed to just be a single message at a time. Okay, for our base, if you've watched my previous videos, my previous Lambda videos, one of them we covered at Lambda and SQS. This is the source code for that, and this is the base I'm going to be working off of. It has main.go, which is a very, very small handler, just in 43 lines, and it sets up a logger and parses in records, basically from SQS. Also has a little helper function just to generate a zip file so that we can upload that directly to the Lambda console. I'll be using this, and you can just clone this down and work with it locally as well if you want to follow along. Okay, so here I am in code, and this is 90% of the way there. This is almost good to go right now. A couple things will change. This is an SNS event and SNS event. So we'll change the event. Instead of being an SQS event, we're handling SNS now. Similarly, let's change this, and we'll change the log statement, and we'll change this to SNS.message. So that is where the payload lives, message.sns.message. For an example of what these messages and what this payload looks like, we can refer to the documentation. Here's an example from the developer guide of a SNS message format. It looks pretty similar overall to SQS, but here you've got the subject and the message. So this would be where the payloads, where your JSON payload or wherever else you would like to encode in, this would be where you put it. And it does have this timestamp here, but this is not the timestamp of when the event occurred in the underlying API or the underlying service. So for our example, the order service maybe processed that order at a completely different time. This timestamp doesn't necessarily reflect when the order actually occurred. So just keep that in mind. Okay, so let's go back to the code here. And one thing I do see, we're saying message, let's say for record. That's a little bit more clear. what we're doing, and let's rename these variables here. All right, so record.sns.message. And we're going to unmarshal that into this event payload. Up here, we have this event struct defined, and this is arbitrary. So for your situation, you would want to define this for whatever payload you're sending into the event. For us, I believe we had an order ID, which was a string, and that was called order ID. And the second one was just TS, and that was just an int, and we just called that TS. So that's what our event payload is going to look like. For your situation, it could be something completely different. And also as well, just in this main, we're using Uber's Zap package here. And this basically just acts as a really clean, simple, structured logger. I prefer it a little bit to just the format.println or the standard library log. So in init, we are setting up our logger, and then main, we're calling lambda.start, and we're passing in the handler for this lambda. This is our handler we defined up here, and this is just going to process all of our SNS events, our messages, and just unmarshal them, decode them, basically our payload, and log the actual event that we got. Let's go ahead and zip this. One thing I forgot to do, we have one more variable to put in. So let's do lambda name. We set that environment variable for both of our lambdas so that we could differentiate the two of them, because the code's going to be the same. So I want to be able to see which lambda is processing what. So let's say lambda name is equal to os.getInv, and that was lambda underscore name, all caps. And this is unused, so let's use this now. We'll add in another field here. We'll say zap any, and we'll say lambda name. Okay. Let's add this to all of our log lines. This is declared but not used. Okay, so it's already been declared above. We don't want to overwrite that in this scope. So this now is setting our global variable, lambda name, and then all of our log statements will log it out. Okay, so that's good. Let's open up a terminal and let's zip this up. I'm going to run our generate zip script, and that is going to create a function.zip file up here, and this is the function.zip file that we'll upload to our lambdas. So let's go back to the Lambda console and let's upload for delivery Lambda, and really quickly under runtime settings, the handler here is specified as hello. So this needs to be whatever you called the binary or executable you generated. So if we look in our generate zip, we're actually generating this as main. So that's the name of our handler. So let's edit this, change this to main. We'll hit save, and we'll hit upload from now, and let's upload our zip file. So I'll find my file and we'll click save. Let's go back to functions and let's do product inventory now. So same thing we did before. Let's change our handler to be main. We'll hit save, and let's upload our zip file. And that's been uploaded too. Awesome. So both of our lambdas now have very basic handlers, and I'm sure in the real world you would have completely different code bases for both of these. But for our case, I'm keeping this purposely really simple, just so we can focus on the architecture and technology that we're using here. Let's go back to SNS and let's publish a message to this topic, and then we'll go view the logs. We'll click orders topic, publish a message, and let's set up our payload. So we'll say order ID, and this needs to be a string, 1, 2, 3, 4, 5, and we'll get the timestamp. TS, and there's the timestamp. All right, and let's click publish message. Okay, so if everything went well, we should be able to go view our CloudWatch logs, backend Lambda. So I'm going to open up both of these in separate tabs again, and I'm going to go to the monitor tab. Monitor, and let's click view in CloudWatch and view in CloudWatch. So we see our second stream now, and that was created at 24:34. So that looks like it was triggered by that second message we sent. And if we open this up now, we see start request ID, but here's our structured logging that we get with Uber Zap. So we get received SNS event. Here's the entire record, and here's that SNS object, and here's the payload within there. And there's the message, the encoded JSON body right here, and we see our Lambda name. So this is for delivery Lambda, and there's delivery Lambda. Let's see the second message. So this should be when we decoded that payload, the event payload, into this JSON object here that we set up. And yeah, there we go. So we see message, decoded event. Here is that decoded JSON object that we decoded into our event struct. And there's our Lambda name again. And we can look over at product inventory, and we should see a similar picture. Yep, there's the first log statement with all of our, with the full record received. There's the Lambda name. And there is our decoded JSON payload that we have in our event struct. So at this point, we've decoded the message, and now it would be up to the consumers to kind of take it and run, do whatever they need to, call out to other services, update databases, update storage, whatever they need to do to finish up processing this message. Yeah, so there we go. That is the video here, and that is how you set up SNS, create a topic, and subscribe consumers to that topic, and then consume those messages and kind of play around with some logs there. Yeah, so hopefully this video was helpful. I often see a lot of these complex architectures with SNS and SQS out there, but I don't typically see just how to actually implement these things. People talk a lot about what this underlying system needs, what we're going to build, but you don't usually see videos that go into depth actually kind of creating some basic workable architecture that you can build off and expand off of. Yeah, so again, hope you found this helpful. If you did, please make sure to like, comment, and subscribe to the channel. Really helps out, helps grow the channel, and lets me know to make more of these videos, and that I'm doing something right. And with that, I will see you all next time.